Hi everyone! Today, I'm gonna show you how to verify and solve an arithmetic sequence. When we say arithmetic sequence, it is a sequence of numbers with a common difference. So, what is a sequence? Sequence is a list of number or anything that are in order. For example number 1, 2, 4, 6, 8, and 10. As you can see, it is in ascending order, and it follows a pattern by adding 2 to get the second term. So what is the second term? So 2 is your first term. 4 is the second. Then 6 is the third. Then 8 is the fourth. And then 10 is the fifth term or the last term. So in this sequence, it follows the pattern by adding 2 to the first term to get the second term, which is 4. So 2, first term, plus 2 to get the second. So 2 plus 2 is equal to 4. Then 4 plus 2 is equal to 6. Then 6 plus 2 is equal to 8. Then last, 8 plus 2 is equal to 10. Then this is the pattern being used in this sequence. Let's have example number 2. Example number 2. Twelve, 9, 6, 3, and 0. This sequence is in descending order. Look at the first term, which is 12. As you can see, 12 is 3 more than 9, 9 is 3 more than 6, and 6 is 3 more than 3, and 3 is 3 more than 0. So what do you think is the pattern being used in this sequence? Okay, that's right. It is by adding negative 3 in each term. So 12 plus negative 3 is equal to 9. So again, what is the rules in adding integers? Okay, different sign, subtract. As you can see, 12 is positive and 3 is negative. So you need to subtract to get 9. Copy? Okay, next. 9 plus negative 3 is equal to 6. Then 6 plus negative 3 is equal to 3. And 3 plus negative 3 is equal to 0. 12 minus 3 is equal to 9. 9 minus 3 is equal to 6. And 6 minus 3 is equal to 3. 3 minus 3 is equal to 0. Let's have example number 3. 1, 2, 4, 8, 16, and 32. Let's try adding 1 to the first term. Since 1 plus 1 is equal to 2, 1 plus 1 is equal to 2. That's right. Then 2 plus 1 is equal to 3. But take note that the third term is 4. Since we don't get 4 by adding plus 1, 1 is not the pattern being used. Let's try another. Let's try to multiply by 2. Since 1 times 2 is equal to 2. 2 times 2 is equal to 4. Then 4 times 2 is equal to 8. Then 8 times 2 is equal to 16. Then 16 times 2 is equal to 32. That's right. So, the pattern being used is by multiplying 2. Let's have example number 4. Sample number 4. 256, 64, 16, 4, and 1. As you can see, it is in descending order. What do you think is the pattern being used in this sequence? Okay, that's right. So some of you might think that it is by multiplying 1/4 to the first term to get 64 times 1/4. So let's show it manually. Let's solve 256 times 1/4. So 256, write it down, multiplied by 1/4. So in multiplying fraction to a whole number, make 256 into a fraction. So just put 1 over here, since 250 divided by 1 is also 256. Then multiply numerator times numerator, then denominator times denominator. 256 times 1 is equal to, that's right, 256. Then copy the division sign. 1 times 4 is 4 is equal to 4. Now divide 256 divided by 4. 25 divided by 4 is 6. 6 times 4, 24. Then subtract. 5 minus 1 is equal to 1. Bring down 6. 16 divided by 4 is equal to 4. Then 4 times 4 is equal to 16. Now we get 64 after multiplying 1/4. Now, let's try to solve for 64. 64 times 1/4. Let's solve it manually. 64 over 1 times 1/4 is equal to 64 times 1. Okay, 64. 1 times 4, 4. Then 64 divided by 4 is equal to 16. 64 divided by 4. 1. 1 times 4 is equal to 4. Then subtract 6 minus 4, 2. Bring down 4. 24 divided by 4, 6. 6 times 4, 24. Then 0. Now, let's try 16 times 1/4. So, 16 over 1 times 1/4 is equal to 16 times 1, 16 is equal to 16. 1 times 4 is equal to 4. Then 16 divided by 4 is equal to 4. And 4 times 1/4 is equal to 1. Some of you might think that it is just only dividing by 4. And that's correct also. 256 divided by 4 is equal to 64. 64 divided by 4 is equal to 16. And 16 times 4 ay divided by 4 is equal to 4. Then 4 divided by 4 is equal to 1. That are examples of sequence. Now, let's proceed to arithmetic sequence. It is very important for you to understand the concept of sequence so that it will be easy in understanding the arithmetic sequence. Let's take a look at the example number 1 and number 2 that I gave to you a while ago. The first two example is actually an examples of arithmetic sequence. Arithmetic sequence. Just remember that an arithmetic sequence is just adding a fixed number to get the preceding term or the next term. Fixed number, then this is the fixed number, by adding a fixed number to the first term to get the preceding term. 2 plus 2 is 4. Then 12 plus negative 3 is equal to 9. And that is actually the concept of arithmetic sequence. And this fixed number is what we call the common difference. Common difference. And it is denoted by small letter d. So, how come it is a common difference? Why not a common sum? Since we are just adding a fixed number. Right? But, guys, it is called common difference because if you choose any of two consecutive terms, then subtract it, you are going to get a fixed number as a difference. For example, let's try 8 and 10. 10 minus 8 is equal to 2. Let's try 4 and 6. 6 minus 4 is equal to 2 also. Then 4 minus 2 is equal to 2. That's why it is called a common difference. Because when you subtract it, you will get an exact or a fixed number. Actually, we have a formula in getting the common difference. Because sometimes, some of the arithmetic sequence is not very easy to identify the common difference. So, we have the formula a sub 2 minus a sub 1, wherein a sub 2 is the second term and a sub 1 is the first term. But you can use also a sub 3 minus a sub 2 and you will get an exact number or a fixed number. This is the formula that you are going to use. Let's have another example of an arithmetic sequence. Given that a sub 1 is equal to 5, common difference is equal to 4. Then find the arithmetic sequence at least 5 terms. 5 terms. So write a sub 1 given, write 5. Then the second term is not given, third term, fourth, and fifth. The question is at least 5 terms. So it is up to you if you are going to add another terms or not. So let's find the second term. So by finding the second term, you need to add the first term to the common difference. So 5 plus 4 is equal to 9. 9 plus 4 is equal to 13. 13 plus 4 is equal to 17. 17 plus 4 is equal to 21. Therefore, your 5 terms in an arithmetic sequence are 5, 9, 13, 17, 21, and so on and so forth. Five, 10, 15, 20, and so on and so forth. Find the 12th term. So by doing manually, 5 first term, 10, 15, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So if you proceed this, you will get the 12th term. But you can also use the formula. So we have the formula for the nth term. A sub n is equal to a sub 1 plus the quantity n minus 1 multiplied by d, or the common difference. So wherein a sub n is the last term or the unknown. So let's have a sub n is equal to a sub 12, then equals the first term, which is 5, plus n is the last term, it is 12, minus 1, then the common difference. So solve for the common difference, just subtract a sub 2 minus a sub 1. So 10 minus 5 is equal to 5. So your common difference is 5. Then solve. A sub 12 is equal to 5 plus 12 minus 1, 11 multiplied by 5. Then equals to 5 plus 11 times 5, 55. 55 plus 5 is equal to 60. So your a sub 12 is equal to 60. So by doing manually, 20 plus 5, 25, 30, 35, 40, 45, 50, 55, and then 60. Let's have another example. Sequence is 4, 8, 12, 16, 20, and so on and so forth. So find the 10th term. 10th term. So use the formula. A sub n is equal to a sub 1 plus n minus 1 multiplied by d. Then a sub n is equal to the 10th term. So a sub 10 is equal to a sub 1, which is 4, the first term, plus n, or the last term, which is 10, minus 1. Then solve for letter D, or the common difference. D is equal to a sub 2 minus a sub 1. So your a sub 2 is 8 minus a sub 1. So 8 minus 4 is equal to 4. So substitute a sub 10 is equal to 4 plus 10 minus 1. Substitute 4 for the common difference times 4. Then solve. A sub 10 is equal to 4 plus 10 minus 1, which is 9, multiplied by 4. Proceed. 4 plus 9 times 4 is equal to 36. Then 4 plus 36 is equal to 40. Therefore, your a sub 10 is equal to 40.